Hello, this is Robert, and in this video I would like to do some arithmetic practice. So I've set up this source code file with several integers from A to E, and then I have a double called dResult and another integer called iResult. And then in this statement right here, I'm doing several arithmetic operations. So I'm doing division, addition, subtraction, and multiplication. So the order of precedence in C++ is the same as it is in a math class. And so division and multiplication come first. Division and multiplication have the same precedence, so C++ starts from the left and then works to the right. So division is on the left, so it goes first, and then multiplication is on the right, so it goes second. You might think to yourself that 9 divided by 4 is going to be 2.25. But in reality, what we have are two integral values right here. These are interpreted as integral because we don't have a point 0. If I was to add a point 0 right there, now the C++ compiler would interpret that as a floating point number. Okay, so 9 divided by 4 will evaluate to 2. Integral division will produce a whole number output, an integral output. So 4 goes into 9 twice. So the result of that operation will be 2 right there. Then we are going to go ahead and do this multiplication to get 4. And so now we have addition and subtraction on the same line. Okay, so 2 plus 2.5, that's 4.5 minus 4. So the result of this entire statement, this entire expression, will be 0.5. Okay, I'm going to undo the changes that I made so that we can see the output when we launch the application. Then let's take a look at this statement right here. Well, we have a floating point number plus a whole number. So this is called a mixed expression. The 4 will be automatically converted to a 4.0, and that's called implicit coercion. There are two sets of circuits inside of the CPU, one to do integral arithmetic, like this, and one that does floating point arithmetic. Well, this is a mixed expression, so we have a floating point number plus an integral. We can express integrals as floating point numbers like this, but there's no way to express 0.5 as a whole number. So what the compiler will do is it will automatically convert 4 to 4.0 and then add 0.5. So we will get 4.5 for this operation, and we have the parentheses there, so we're overriding the precedence. Since we have the parentheses there, addition goes first and then division will go second. So what we'll have is 8 divided by 4.5. So let's go ahead and replace that expression with the result, which will be 4.5. Now we have another mixed expression, 8 divided by 4.5. That will evaluate to 1.77. But we have to be careful here because notice that we are storing 1.77 into an integer right there. Okay, so integers will only store the whole number part of the result. So what we will get is we will get the 1. We will get the whole number stored in iResult, and then 0.77 gets thrown away. Okay, and I'll undo my changes so that we can see those in the output as well. Okay, so then we just have two cout statements right there. Now let's take a look at the increment operator. So we have E++. E was initialized to 2 up here, so if we say E++, that will store a 3 in E. Okay, so when we say e plus plus, that means take the value of e, add 1 to it to get 3, and then store the 3 back in that memory location. So this is a left-hand value because it's on the left side of the assignment statement, and this is a right-hand value. It's very common to do the increment operation in C++, so that's why there's this shorthand right here. There's two ways that we could increment e. We could put the plus plus after it, or we could put the plus plus before it. And since there's only one variable here, it will mean the same thing. When we combine increment with other operations such as addition, that's when things change a bit. There's also a decrement operation. If we would like to use decrement, we can just use minus minus right there. So that means the same thing as e equals e minus 1. I can put the minus minus in front, or I can put it behind. It's a common mistake to combine this notation with this notation. So this will increment e. Don't combine the two to have something like this, because this means increment e, or decrement e in this case. So e would go down to 1, and then store 1 into e. Okay, so this is almost nonsensical. Depending on the compiler that you're using, you might get a strange error. We can store the new value in e with just this one statement. So minus minus right there means take away 1 and then store that value back into the variable. So let's take a look at this statement right here where we have a combination of addition and incrementation. Okay, so the plus plus is in front of the variable b. So that's called pre-increment. Then in this statement right here, we have plus plus after the variable d. So that's called post-increment, and it all has to do with the order of precedence, or the order of operations. Since the plus plus is in front of b, that means do it first. So it takes precedence. B is 5, so we will now add 1 to b to get 6. And then what we'll do is we'll take 3 and we'll add that to 6. So we'll store 9 in iResult. So let's just put that right here. So result is 9 and b is 6. In this example here, we have post-increment, which means that the addition of 1 will always be done last. Even if we place parentheses around this, there's no way to do the precedence any other way. So D will get 10 no matter what, and it will be done last. Okay, so the parentheses don't change the order of precedence when we're doing increment. Because we're doing post-increment, what we will do is we will get the value of C, which is 7, and then we will add the value of D, which is 9, and we'll take that value, which is 16, and store that into iResult. So let's go ahead and place that right here. Result is 16. And then after we do 7 plus 9 to get 16, we'll go ahead and increment D. So at this point, D will go to 10. So that increment will be done last in order of precedence. All right, let's go ahead and run this and see what we get. Okay, so D result is 0.5 like we expected. We have the 2 plus 2.5 is 4.5 minus 4 to get a half. Then all of the operations on the right side of the equal sign here resulted in 1.77 because it's mostly a mixed expression, a mixture of integrals and floating point, but then we stored that result 1.77 back into an integer, and so what we got for output was just the 1 right there. Then we're going to be doing our increment and operations, our pre-increment and our post-increment. So A was 3, and then we had B, which was 5, which we can see right here, but we added 1 to it, so that equaled 6, and we did the incrementation first, so we got 6 plus 3 to get 9 as our result right there. And then in the post-increment version, we did C plus D first. So we got 7 plus 9 to get 16, and we can see 16 right there. But then we added 1 to D to get 10. Okay, so pre-increment and post-increment is all about precedence when we have other operators in our statement. Okay, so I hope that was some clarification on some of the different arithmetic we can do with different data types.